and welcome to this presentation. My name is Tazon and I'm happy to present you my research which is on large language model for ontology learning. Research done together with Dr. Azanzi Jomokong and Dr. Oktay Hassanzadeh. So here is the structure we are going to follow during this presentation. Then without no more delay, let's start. Ontology learning is automatic extraction of ontological knowledge sources, different sources, structured, semi-structured, and unstructured sources. It helps because it's used to organize and structure knowledge, but this field faces problems such as knowledge evolution, heterogeneous data, and etc. But to solve that problems, we have the combination of rules to large language models. Then, some of these problems were highlighted during the large language models for ontology learning challenge, which is a challenge that aims to explore the intersection of large language models and ontology learning. During that challenge, we had to handle three main tasks, which are term typing, taxonomy discovery, and non-taxonomy relation extraction. And for each task, a set of datasets were given, by example, WordNet dataset for term typing, schema.org for taxonomy discovery, UMLS for both non-taxonomy relation extraction, taxonomy discovery, and term typing, and etc. Each dataset had its own characteristic, as you can see on the presentation. And to evaluate our approach, a set of metrics was given such as precision, recall, and the F1 score. After going through the different datasets, learning about these metrics, and choosing our large language model, we define our fine-tuning workflow, which is as follows, and comprise two main stages. The data preprocessing stage, which involves passing our dataset through a battery of preprocessing operations to obtain more structured, more usable data, as you can see from the following figure, which shows a concrete example. After that, we were able to define our annotation workflow, as you can see here, which is made up of four main stages whose final aim is to obtain the final annotated submission file. The first step, of course, is data preprocessing, where our data goes through a transformation battery to make it more usable. Then we have the has double types module, which takes each entry in the prediction file and checks if more than one type, at least two, have been predicted by the model. If so, then that entry will go into our script, which contains the rules that have been highlighted by browsing the data provided by the organizers of the challenge. And so we get our final submission file. This enables us to move up from this position, which was last in the rankings, by going through the data and also by setting a pipeline to extract the rules from the data, as you can see, to some pretty interesting results like those you see, and thus to position ourselves at the top of the challenge for the WordNet dataset, and to increase our scores for the other dataset too. Here are the figures presenting our position on the other datasets. All this work was done using a lower power environment as described here, and the reproducible code is available on this GitHub repository. I'd like to thank each of the institutions that made this work possible. And a big thank you to each of you for listening.